Hello, so welcome to Math2526. Okay, so today's topic is one-way table, two-way tables. So the problem is just like that. Like at the end of the semester, we have the grade for each class, right? So here we have this table. We have 3 classes. So for class 1, we say how many A, how many B, how many C, how many D or F. We have this table is the grade table for 3 classes, right? Okay, so we call such a table as a two-way table. Like this is one-way classes, right? So another way is grades. Okay, so this is two-way table. So what is one-way table? One-way table is just we have only one class, right? So we have only this way, like can change, right? So this way cannot change because we have only one class. Okay, so this is one-way table, two-way table. Okay. So for the typical problems, or typical questions for two-way table is we just check like changing this direction make a difference, changing this way make a difference, or changing this way make a difference. Like for this example, maybe we are interested in this direction, right? So like different class have different distribution for their grade, right? So changing this direction is the percentage for getting A, getting B or C, distribution for getting A or B or C or D make a difference. So we see this difference, we are sure they have a difference. Cannot be getting percentage of getting A or getting F should not be the same, right? Okay, so for such a problem, we have interest in this direction, right? So we have those questions. Is there significant difference among these classes based on their grade distribution? Okay. So this is a typical question for two-way table. Changing this way make a difference, changing this way make a difference, just like that. Okay. Okay. So for one-way table, we also can for one-way table, we can ask changing in this changing in this direction make a difference. But such a question here is not so interesting, right? We know the percentage of getting A or the chance to get A or B or C or D, F. Their percentage should not be the same, right? So we say such a question is not so interesting. They're the same or not the same. So for one-way table, we will ask a more interesting question, like this, like whether our class, the distribution in this class match some model, or is there great inflation in our class? Okay, so such a problem, we can say, is the data do the data match the model, or let's say great inflation. So what inflation means? Inflation means not match the model. Like for example, for other here for our class for getting grade A is like 30%, right? But for other class is only 20%. So this means that the chance to getting A is too high, or not, maybe not match the model, or maybe have a grade inflation. Okay, so such a problem is a two-way table, one-way table problem, or one-way table, two-way table problem. Okay, so this is today's topic: one-way table, two-way table. Okay. So let's say, so how can we check those one-way table, two-way table problem? At first, we convert such a problem as testing problem, right? So here, our hypothesis is there's three classes, no difference. Okay, and HA have a difference. So we say such a problem is just like many sample problems. So only difference is the data type not the same. Like for many sample problem is for class 1 data is just we say we compare three classes based on their final performance, final exam performance, right? So for class 1, the data is the exam scores. Okay, so we can compare the average, right? Average for class 1, average class 2, and so we say that here those data are categorical data. So we have those notation: numerical data, and categorical data. Okay. So the question is the same. We say if we have three classes, we want to compare, right? We want to check they are the same or not the same. They have difference or no difference, right? So here we say this data is categorical data. How many? Like we have this categorical, like A, like categorical A, category B, like C or D, and then put those numbers in each category. Okay, so we say the hypothesis is same, no difference, right? H is maybe have some difference. Okay, so on the HO, if we believe no difference, then we can put these three classes together. Okay, so we can put these three classes together. We can have regarded three classes as one class, right? Okay, so in this class totally we have number of students. Then we have so many A, so many B, so many C, so many D or F. Okay, so here we have this percentage for getting A is thus like 15 over 90, right? Among 90, we have 15 students can get A. So this is we can say that this is the percentage or the chance for getting grade A. So we denote this as a PA hat means like from the data. Okay, so according to this percentage, like for getting A is this, then we can check how many should be here, should be this cell. So here's 6, but so we say 6 is observed data, true data. But based on this percentage, how many should get A in class 1. So we call such number as expected value. Okay. So we have many expected value. Like was in this cell, expected value. In that cell, like how in this cell, in each cell we can find expected value. So we the expected value in this position we denote this as E11, meaning E11 means class 1 and categorical 1, right? So this number is E11. Okay, so class 1 category. So we cover so E12 means this position, right? Class 1 categorical 2. So class 1, how many in class 1 can get grade B, right? So how can find this expected value? Just equal to the percentage. According to this percent, totally we have 30 students, right? In class 1 we have 30. So according to this percentage, so percentage multiply total is supposed number is 5. So we call this number should be supposed number should be 5. So this 5 is expected value, and this is 6. So we can regard this 6 as observed value. We also can denote this observed value at this position, and this 5 is expected value at this position. Okay. So for each cell, we can find expected value. So then, whether our assumption is true or not true, we just check whether those observed value and expected value quite close, right? So how can we determine that close or not so close? So we can use like this square, right? Okay. So we can say the basic idea is if observed value and those expected values are square and them add them up, if such number is very small, then we can say expected value and observed value quite close. Now, quite close means our expectation or our assumption is true, right? Okay, so here at first, so we need to understand those notation, expected value at this cell, at that cell. Like let's say, what is this meanings? E23. So E23 means class 2, right? 3, category 3. So this number, the class 2 get grade C. So 10 is observed value, right? So we want to find expected value. So let's say we also can denote this as observed value to 3 is 10, right? Class 2 get grade C is 10. Okay. So this is E23. How can we find E23? So this equals the percentage for getting C. So percentage of get C is amount 90. Total 90. We get C is 30, right? 30 get C. So this is the percentage for getting C. So according to this percentage, so multiply this percentage, multiply total students, total number of students in class 2 is 32, right? Yeah. Okay. So this number is E23. Okay. Well, so just some calculation, right? So let's say 30. Okay. So this is just 32. Okay. So we say, this is 10.7. Okay. So those are expected value. Okay. Okay, so then how can we judge expected value and observed value are quite close. So the test statistic is thus. So this is so summation is for each cell. We have observed value, so minus expected value is square, but here we need to divide by expected value. Okay, so here y divided by, so we say why is this not work? Just we say this formula is quite simple, right? Why is this not work? We just check each observed value minus expected value is square. So if this number is small, then we say expected value and observed value are close, right? So why we need this? So this is just like standardized, generally or normal. We say this is just from generally, just like generally or normal. Normal. We wanted to change it to standard normal, right? We wanted to standardize standard. So from generally or normal distributing to standard normal, we need, remember, x minus mu divided by sigma, right? So here, just the same idea, okay? Okay, but anyway, we just use this formula to calculate this cut point or test statistic. Okay. So this formula is like each observed value minus expected value square, then divided by e. So here, let's say, so like first, let's say, so for this cell, first cell observed is value 6. So we want to find 6. So minus expected value 5 square, right, over 5. So this is first cell. Then plus second cell, right? No, this is, we call this chi-square, right? So first cell, second cell. So we say we have 12 cells. So such calculation is tedious. So we say for those tedious calculation, we just need to use a computer. Okay, so we say, so I will not ask you to do those tedious calculation. So I will say, like, so we use a computer, right? So from computer, we get this value equals this. Okay. Okay, so then the problem quite the same, like okay, so we have this number 2.16. Then we need to determine like this big number or small number. So this big or small. This is what we want to determine. Okay, big number, small number. So how can we determine this is a big number, small number? Then we need to check a table. So there's a table called a chi-square table. So we need to find those critical value. We call this a chi-square value. Let's see. Okay. Okay. So we need, let's say, find chi-square. So we say critical value, right? But anyway, we need to find this number so to determine this is big or small. So we need to check a chi-square table. Okay. So this chi-square table, just like a T table or F table, they have a degree of freedom. So for two-way table, we have this formula equal R minus 1 times C minus 1. So what R means? So R means number of row. R. Okay. Oh. Okay. Excuse me. No. Okay. So let's. Oh, I'm sorry. Oh, here. Okay. R is number of rows. Okay. And C, so you understand C is number of column. So here let's say go back to, I'm sorry. Go here, so R is 3, right? We compare 3 group, 3 classes. And C, how many columns? How many categories? A, B, C, D, or F. So 4. So here degree of freedom is R is 3, so 3 minus 1, 4 minus 1, so that's equal 6. Okay. So then let's check this chi-square table. Find those critical value. Okay. Okay. So we need to check a like chi-square table. So let's say, so we need to check a chi-square table. So here is a chi-square table. Okay. So this chi-square table, so this means like, so it's a cut point, and this is probability. So here, so it's a probability, and then so the cut point. Okay. So now let's say, so we check a degree of freedom is 6. Okay. We need degree of freedom is thus 6. And so probability, we make it, what is it, 0.005. So we find this number is thus. So this is, let me write it down, 12.592. So this is cut-off point. Okay, cut-off point. Oh, this is a if. Sorry, the chi-square critical value. Okay. So now let's go back to here with a chi-square critical chi-square value is 12.592. Okay, so this means like we use this number to make our decision. Like this number as our standard. So here's small number, less than this number we regard as small, and larger than this number we regard it as big. Okay, right? Okay, so over number is here 2.16. So we can regard it as a small number. So small number, our decision is If it's a small number, so decision is no difference, right? So we can go back to, so we can answer this question. This three here, these three classes, their grade distribution, no difference. Okay, so this is an example for two-way table. Okay, so two-way table is also simple. First one, we need to know how to find expected value. Then for chi-square value, usually I will tell you because the calculation is tedious, right? So once I give you this chi-square value, so you should be able to determine this number. This number is a big number or small number. I will determine this test statistic is big number, small number. If this number is small, then we can say no difference is not so significant. Right? If this number is a big number, you can say, oh, difference is big. Right? Okay, so now let's check some more examples. So here, okay, so here we want to compare whether men and women are different. So here we compare two groups, but we have for those people we set the three categories, right? Okay, so at the first let's say want to find this expected value. What is E11? So what is E11 is what is number should be here. So this 2 is observed number. Is 2. So we want to find E11. So E11 is so how can we find E11? So we say if we regard this there's two men and women, no difference, we can put them together. So 18, right? So we can say 18 people like dance. And totally how many people? 50, right? So we can say here we have 50 adults, 20 men and 30 women. So among those 50, 18 people like dance. So there's a percentage for like dance is 18 over 50, right? So there's a percentage for like dance. So for men, totally how many men? We say 20, right? So women 30. Okay, so we just multiply. So we have 20 men. So according to the percentage, so this percentage multiply 20. So this equal E11, right? So we can easily calculate E11. Let's just say this equals okay. So we say this should be equal 7.2, right? So this 7.2 is a number supposed to be if we believe men and women are the same. Okay, so for each cell we can find those expected values. So here we have 6 cells, right? We have 6 of them. So then we, based on computer software, we can find this chi-square value. So chi-square value, the formula is thus, right? Summation, also observed value minus those expected value, it's square. So divided by expected value. So we find this number is thus 10.3. So our decision is we just need to determine this big number, small number, right? So here 10.3. This number is big number, small number, or this distance to the 0 is big or small, or there's two number like 0 and 10.3 is quite far away or quite close. Okay, so for these things we need check a chi-square table. Okay, so in order to check the chi-square table, we need to determine degree of freedom. Okay, so use this formula: r minus 1 times c minus 1. So here, what is r? So r equal 2, right? So there's r equal to 2 minus 1. And what is c? We have 3 categories. So c is 3 minus 1. So this equal 2. So degree of freedom is equal to 2. And the significance level is 0.005, right? Yeah. Can we, so usually, here no alpha. If there's no specify this alpha, tell us alpha, then we, by default, we use this alpha. Okay, 0.005. Okay, so now let's check this chi-square table. So let's go to chi-square table. Okay, so degree of freedom is times 2. And alpha 0.005. Okay, so this is we call the critical value. Chi-square critical value is 5.991. Okay, so then we just check it. Okay, use this, so we can determine this big number, small number, or we say critical value equal is 5.991, right? So this number is come from the F table. So use that. So okay, so we find this. So use this as standard. So this is small, this is big. So we say this big number. So this number is big. 10.3 is big number. So if this is big number, then your decision is man and woman are different, right? Their difference is significant. Okay, so we can answer the question. So question, no question here. I'm sorry. So question is whether the woman and the man have different favorite leisure activities. So we say man and woman do have a difference, right? Like a woman like dance more than man. Okay, but anyway, so this is like a two-way table, a two-way table problem. Okay, so this so this is today's class topic: one-way table, two-way table. Okay, so one-way table, two-way table. Okay, so for those kinds of problems, we just find a cut-off point, or a cut-off point or test statistic. So we call this a chi-square value, right? Chi-square value. So based on this formula, find this cut-off point, then determine whether this cut-off point here, cut-off point and 0 is big or small, right? This number is big number, small number. So how can we determine this number, big number, small number? So check chi-square table, find those critical value, right? Use critical value to determine there's a big number, small number. So if there's a big number, we say, oh, they do have a difference. If there's a small number, we say no significant difference, right? Okay. So this, okay. So this is we just check the two examples for two-way table. So next class we will check a one-way table problem. Okay, so we can stop here.